Hello guys, welcome to today's lesson. We'll be doing tutorial sheet 6, question 3. So question 3 reads, a string of length 30 centimeters has one end attached to a fixed point and the other to a mass of 100 grams, which revolves in a horizontal circle 80 times per minute. 80 times per minute. Then we are supposed to calculate the angle of inclination of the string to the vertical. So that's theta. And we also have to find the tension in the string. So tension. So we've got two tasks: find the tension and find the angle of inclination. So if you look at the diagram that we have here, we have a rope here and it is making an angle here with the vertical. So we're supposed to find this angle and calculate the force theta. So now we've got this ball that is going around this circle. Now, as this ball is going around this circle, there's a force, a centripetal force that is acting towards this ball with reference to the center. That's the centripetal force. And then we also have the tension force that is acting due to the string. So meaning we've got these two forces. And another force that is acting on this body is its weight. So if we try to draw a free body diagram, we'll end up with we have a ball here, and it has a string. Okay. So here it has the weight acting on it and the tension force which is there. So now we've got the force which is Fc, the centripetal force acting on the centripetal force that is acting on the body. So now if you look at the tension, you notice that the tension is acting at an angle. Okay, since it is acting at an angle, meaning that it is acting in component forms, it has got the force which is the vertical component, and the component is balancing with the weight of the body, and then there's the vertical component which is also acting on this. So we've got this vertical component which is, so if this is theta, then this is also going to be theta. So the vertical component is T cos theta, then the horizontal component is T sine theta. So that's what we have. We've got these forces acting on the body. So now if we talk of forces in the x and in the y axis, summing up all the forces that we have, we'll start with the forces in the y axis. Right? So summation of forces in the y axis will give us a resultant of 0. Okay, because it is not the object is not in motion at any point in the y-axis. So we're going to say that the resultant of the forces is equals to 0, and that is equal to the weight, which we are going to take as negative downwards, and the tension, which is the vertical component of the tension, will be taken as positive if it's going upwards. So meaning we are going to have the top as positive and the bottom as negative in the y-axis. Then in the x-axis, we're going to have the motion of direction as positive and the opposite as negative. So we're going to have the forces in the y will be the tension, which is T cos theta, minus the weight because it is in the negative, and that will give us 0. Then what about in the x-axis? So the summation of forces in the x will be equal to, now we'll have the summation of, that's 0. So meaning that we have got the, okay, I think I made a mistake with the direction here. The centripetal force is acting towards the object, so meaning it is in this way, it's in the opposite direction, whilst the tension force is in this direction. So meaning that we have got the tension force minus the centripetal force. Okay, that's what we have, which is going to be equal to 0. So another thing that we have that we can look at here is the radius of this circular path. What is its radius? We have got the length of the string. How do we find the radius? Mind you, the radius or the string is making, the string is making an angle with the vertical, which is here. So from the from trigonometry, we can say that the radius of this circular path is equals to L sine theta, the same theta that we have here. So if we get that the same theta that is here is the theta that is here. So if we refer to this theta, we are going to get L sine theta. That's what we're dealing with. So now we are going to concentrate on the motion in the x-axis so that we'll be able to get t, okay, t sine theta equals the centripetal force. Now, the centripetal force is equal to mv squared over r. So we've learned that v is equal to r multiplied by the angular velocity. So since that is squared, we divide it by r. So we are going to say the tension sine theta is equal to m r omega squared. Okay, that's what we have. So now, what is r? Okay, r is the radius of the circle, and here on top we've said the radius of the circle is equals to L sine theta. So you'll say that t sine theta is equal to m. The radius is L sine theta omega squared. So that's what we have there. Okay, we have an equation that we can use to now find the tension of the string. So we've got sine theta this side and we've got sine theta this side, so we can divide them through, and then our tension will become m L omega squared. That will become our tension, and that will be easy for us to calculate because we've got all this data here. So m to start with is 0.1 kgs multiplied by L, which is 0.3. All right, 0.3. Since that was since that was 30 centimeters, so 0.3, not 0.03. Okay, so now we have 0.3 multiplied by omega squared. Now omega, we've been given that it is 80 revolutions per second, per minute. So we can change that. It will be 80 revolutions per minute. Then we multiplied by 2 pi radians, since we want to end up with the radians on top, divided by 1 revolution. Then we multiplied by 1 minute divided by 60 seconds. There. So we'll have the minute dividing with the minute, the revolutions dividing with the revolutions, and then we are going to have going to have to calculate that, so that we'll have 0.1 multiplied by 0.3 multiplied by 80 multiplied by 2 pi. That gives us 15. Then we divide by 60 and we get sorry about that. So we'll be able to get the tension as 2.105, which we can equate to 2.1 newtons. Okay, so that's the tension in the string. So now, how do we go about calculating the angle? Okay, if we go back to the summation of forces in the y-axis, it can help us to calculate the angle. We said that tension cos theta minus the weight is equal to 0, right? So we can say that the tension cos theta is equal to the weight of the object. We've already calculated the tension, so we can say cos theta is equal to mg divided by t. And if we substitute, we are going to get theta is equal to cos inverse of mg divided by t. And that will give us cos inverse of 0.1 multiplied by 9.81, everything divided by the tension that we've just calculated, so we'll have 2.1. And then we're going to find that theta is equal to 62 degrees. Okay? So that's what we have there. That's the answer. That's the angle that it makes with the vertical. So we've calculated two things. We've found the tension in the string, which is 2.1 newtons, and we've also found the angle that the string makes with the vertical, and that angle is 62 degrees. So now we go to question 4. So question 4 reads, if you go back to the question, a 450 grams ball at the end of the cord is whirled in an almost horizontal circle of radius 1.25 meters. So its tangential speed in the circle is 8.5 meters per second. Do not neglect the weight of the ball. The string cannot be perfectly horizontal. What must the tension in the cord be? What angle does the cord make with the horizontal? Okay, so if we collect data, we've got the mass, which is equal to 0.45 kgs, the radius, which is equal to 1.25 meters, and it says that its tangential speed in the circle, which is the tangential speed, we're talking about the velocity, which is equals to 8.5 meters per second. Okay, so that's the information we have, and we're supposed to find the tension and the angle it makes with the horizontal. Now, this question is not so different from the question we're just from doing. And that's question 3. It's not so different. The only thing is that question 3 was asking us to find the angle that it makes with the vertical, but this one is asking us to find the angle that it makes with the horizontal, and it also wants us to find the tension. All right, so we've got a similar situation. We have a ball that is moving in a circular path, and there's drawing is not good, but okay, is that. So we are looking for the, we can call this alpha and we call this angle theta, whichever you want you can get. So this ball here, just like the ball in the previous question, has the weight, sorry, it's got the weight mg acting on it, and there's the tension which is acting in components. We've got T, if we look at the angle here, we've got T cos theta, we've got T sin theta, that's what we have there, and we have got the centripetal force as well acting there. So we have the same setup as we had in the previous question. So now, how do we go about this? We are going to use similar ways of solving this question now. We have the forces in the x-axis summing up to 0. And that is equals to T cos theta being equal to the weight. Alright, then we also have the tension, summation of forces in the y also adding to 0, meaning that the tension, the horizontal tension is equal to the centripetal force, and the centripetal force is equals to mv squared over r. So with this one, we don't have to convert to the angular speed because we've already been given v. It's not necessary. So we've got equations that we can write there. So we have T sin theta is equal to mv squared over r. Then we also have T, we can call this as our equation 1. Then we also have T cos theta being equal to mg, and that is our equation 2. So if we divide equation 1 by equation 2, we are going to get tan theta, because sin theta divided by cos theta is tan theta. Tension divided by tension is 1. Okay, so that will give us mv squared over r divided by mg. I've written like this so that I don't have to write the fraction, but I'll write it this side. So we have now tan theta is equal to, so in fractional form, tan theta will be equal to v squared divided by rg. So the m's have divided through, okay? So we have got these values. So now what is theta? So theta is equal to tan inverse of v squared over rg. That's what we have. So theta, if we substitute our values according to how the values we've been given, we find that v is 8.5 squared divided by our r is 1.25 multiplied by 9.81 there. So meaning that theta is going to be equal to that's 8.5 squared divided by 1.25 times 9.81. So theta will be equal to 80.36 degrees. So if you look at theta, we go back to our drawing. Theta is the angle here, the angle that the rope or the thread makes with the vertical. But the question has asked us to find the angle that the cord makes with the horizontal, and the horizontal is this. So meaning the angle we are looking for is the angle which is here, the angle that it makes with the horizontal. For us to find the angle that it makes with the horizontal, since this is 90 degrees, we can simply subtract 80.3, the angle we've found right now, from the 90 degrees, and we'll be able to get the angle alpha there. So alpha, to get alpha now, alpha is equal to 90 minus theta, which is equal to 90 minus 80.36. So meaning that alpha is equal to 9.663. 63 degrees, surrounding of figures. So that's what we have. That's our angle, the angle that it makes with the horizontal. So about theta and alpha, you can use whichever you're comfortable with. This can end up as theta, that can end up as alpha, or you can make it easier for yourself by, instead of the way I went about solving this equation where I was working with theta, you can just work with alpha. Okay, so now if you're going to be working with alpha, you're going to have to be careful that you find the components properly. So if you're working with alpha, you're going to look at this value which is here and relate it to the value on top there, and then the value which is this side, you relate it with the value that you can get this side. So meaning the tension will be here, and then you're going to say the angle is here. So you have T cos theta, which will be this side, and then T sine theta, which will be this side, because now you'll be dealing with this angle. All right. So you can work with whichever you are comfortable with. I am more comfortable with working with the vertical axis and then subtracting that. But if you like, you can just go direct where you work with the angle here, which is the horizontal. Okay, right. So then the next part is we're supposed to find the tension. How do we go about finding the tension? So in a similar way that we found the tension in the previous question, we can use the fact that tension cos theta is equal to the weight of an object, and then cos theta is equal to the weight divided by the tension, and theta will be equal to cos inverse of the weight divided by by the tension. That's if we're looking for the tension, but in this case we are looking for theta. We already have theta, we are looking for the tension, so it's supposed to be tension. Okay, so this has error, it got carried away. So tension is equal to the weight of an object divided by the cosine angle. So in this case, I'll put alpha since I used alpha there. So alpha. So tension is equals to sorry. At this point, we have to substitute. So the weight of the object is 0.45 multiplied by 9.81 divided by cos. Okay. Oh no, I can't use alpha. I have to use theta, because then I'm going to confuse the whole thing. I have to stick with what I used to find the angle, because either way the tension will be the same. So cos theta is going to be equal to, so that will be cos, the value we found, which was 80.36. Okay, so now the reason why I have not used alpha here, just to explain a bit, had I used alpha here, if I had found the components using alpha, they would have been in the opposite, they would they wouldn't have been the same. Mind you, if I use alpha, meaning that this will be t cos theta, meaning this value will be here, right? And the value which was here will be here. So now if I use alpha here, if I use alpha here instead of theta, meaning that I'm going to get the wrong results, I use theta to calculate the angles. Okay, I used theta to calculate the angles, so that means that's the same theta that I'm going to have to use to calculate the tension. If you use alpha to find the components of the vectors and the angle, then you're going to have to use alpha to find the tension as well. So meaning that the tension okay, so the tension will be equal to 26.4 newtons. Okay, that's what we have. So now we are going to question 5. We solve question 5 and that will be that for today. So question 5 reads, a wheel of radius 25 centimeter has 8 spokes. It is mounted on a fixed axle and is rotating at a constant angular speed. You shoot a 20 centimeter long arrow parallel to the axle through the wheel at a speed of 6 meters per second. The arrow and the spokes are supposed to be thin. Calculate the maximum value of the angular speed in radians per second and revolutions per second so that the arrow just goes through without hitting any of the spokes. Does it matter where between the axle and the rim of the wheel you aim? If so, what is the best location? Okay, so we've got a drawing here. Okay, in this drawing we've got this wheel and it has 8 spokes. So the spokes are those that I'm making. So if you look at it, you count 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 spokes. Okay, so this is moving. As it is rotating about, you aim or you shoot an arrow which is 20 centimeters in length to pass through one of these. Okay, so meaning that this space, as this is rotating, the 20 centimeter arrow is also supposed to pass through without being disturbed. All right, so meaning this shouldn't move too fast and it shouldn't move too slow. It should have a certain speed that it will move at, so that this is going to be the arrow is going to pass through smoothly without hitting the spikes. All right, so now, well, how do we go about finding this question? Let's first write the data that we have been given in the question. Okay, so the data we've been given is that R, radius of the spokes, is equal to 0.25 meters. Then we've also been told that the velocity is equal to 6 meters per second. Then we've been given the length of the arrow, which is equal to 0.2 meters. Yes, another information we've been given is that this this wheel has got 8 spokes. Now, if we have a wheel, okay, if we have a wheel there and it has 8 spokes, right? If it has 8 spokes, then meaning the 360 degrees that we have has been divided into 8, okay? Or the 2 pi radians that we have has been divided into 8, okay? That's what we have. So we can say that the value of each spoke in terms of angles or angular displacement will be equal to 360 divided by 8, which will give us 45 degrees. Now, 45 degrees can be converted to radians by multiplying it by 2 pi radians divided by 360 degrees. So that will give us 0.79 radians. Okay, that's what we have. We have 45 degrees and we also have 0.7 radians. That's what we have. So now, the information that we've been given is that this wheel has to move at a certain speed, okay? And that speed we've been given to say it is 6 meters per second. And the distance that this wheel will have to cover in angular terms, we are yet to find out. But we've been told that an arrow of 20 centimeters is supposed to pass through here, okay? Meaning that the speed of this wheel should be equal to the speed of the arrow. Otherwise, they will crash. So we are going to take the speed of the wheel as the speed of the arrow. Yeah? So the speed of the arrow, we've been told in the question, is that the speed of the arrow is equal to 6 meters per second. Okay? And then the length of the arrow, which is like the distance, is equal to 0.2 meters. Okay, so if it's moving like this, it's going to have to cover this distance at this speed. So we can use the equation for speed, which is speed is equal to distance divided by time, where time is equals to distance divided by speed. So our distance is equal to 0.2 meters and our speed is equal to 6 meters per second. So that will give us the time of 0.33 seconds. Okay, that's how long it's going to take this arrow to completely pass through this wheel without being disturbed. So if it's going to take that long for this arrow to pass through this, which means it should take just as much time for this wheel to be able to rotate about, all right, given a certain whichever spoke we are going to look at. So if there's a spoke here and you aim your arrow into this spoke, it should take 0.33 seconds for it to completely cover a certain angle. So now, how do we go about finding the angular speed of this wheel? So we can use the formula angular speed, okay, is equal to change in angular displacement divided by change in time. Okay. Now this wheel obviously started from rest. Okay. So we are going to say theta final minus theta initial divided by time. Okay. So we'll get the theta initial is 0. So we'll just talk of the theta final divided by time. So our omega, or angular speed, is going to be equal to, we've said, each spoke is equals to 0.79 radians. So meaning that's the angular displacement that each spoke is going to cover. Then divide that by the time, which is 0.33 seconds. Okay. When we divide by the time, we'll get the angular speed as 23.8 radians per second. Okay, so that's what we have in radians per second. But the question has also asked us to find the speed in revolutions per second. So we know if we convert that, 23.8 radians per second multiplied by how many revolutions are in 1 radian. So 1 revolution is equivalent to 2 pi radians. The time is okay, so radians will divide with radians and we'll have 23.8 divided by 2 pi revolutions per second, and that will give us 3.79 revolutions per second. That's what we have there. Okay, so that's been calculated. Now, does it matter where we aim, where the axle and the rim of the wheel? Okay, like between, if you look at it with reference to this drawing. Okay, does it matter where you aim your arrow? Like, should you aim it here? Should you aim it here? Should you aim it here? Does it really matter where you aim it or not? Okay, so the answer is it doesn't matter. Okay? It doesn't matter where between the rim and the axle the arrow is aimed. Okay? Angular speed and theta between two spokes are the relevant quantities. Okay, the position doesn't matter, so the angle is the same. Okay, here the rotation, the speed of rotation is the same. Okay, it doesn't matter. The particle here will move in the same speed and so on and so on. So wherever you're going to hit it, it's all right. Okay, as long as it's going to pass through the same spoke. So that's that. Okay, so today we are going to end there. Now I've got an assignment for you. I want you to do question number 6 in the tutorial sheet. Okay, question number 6 in the tutorial sheet, which is this one here. Yes, you do it together with question number 10 in your tutorial sheet. So the hard copy I have doesn't have question number 10, so you do assignment. Okay, assignment, you do question 6 and question 10, and then send it via email to Nonde Elizabeth. Everything is in small letters. It's at yahoo.com. Okay, so take note, this has got 2 E's, it has got no H, it's just Elizabeth. So Nonde Elizabeth at yahoo.com. Send the questions, as in the answers to the 2 questions in the tutorial sheet, and then I'll look at them, seeing what you're doing. So in the next video, we are going to do questions 7, 8, and 9. Okay, that's all for today.